Hey guys, Mr. Mailhot here for some bridge to college math. Let's do some problems. We're talking about equations and identities. Remember, for our purposes, identities mean equations that are always true. Always true, meaning no matter what you plug in, no matter what value you plug in for the variable, both sides of the equation are always true. Let's look at these problems here. So directions say, for each of the following statements, indicate whether it is always true, never true, or sometimes true. Circle the correct answer. If you choose sometimes true, then state when it is true. They did have one as an example for us. So this x plus 2 equals 3. Well, yeah, I mean, that's sometimes true. I mean, it can't always be true. If I plug in 5 for x, 5 plus 2, or 7, is not equal to 3. But I do know it is true when x equals 1, right? Because 1 plus 2 is 3. All right, let's try one. Some of these you might be able to do by just looking at them. Others you might need to do a little bit of work. It's fine. You don't have to actually get to solving them, although that might help you out. Let's try this one. So x minus 12 equals x plus 30. I mean, without solving it, you might have a guess, right? Because these two variables, x and x, no matter what I plug in, it's going to be the same for both of them. So if I plug in a 10, we got 10 and 10. If we plug in a negative 7, we got negative 7 and negative 7. From one of them, we're going to take away 12, and from one of them, we're going to add 30. That's doing two different things. I'm leaning towards never true, but let's prove it. Start acting like you wanted to solve this. Go through some steps like you wanted to solve it. Get the x's on one side, numbers on the other. Minus x to get our x's together. Well, let's see. X minus x is 0. It's gone, so we have negative 12. And, oh, that's also 0, right? X minus x is also 0. Now, is this true? Is that true? Is negative 12 equal to 30? I hope, like, if it is, I don't know what I'm doing for my job, but I'm pretty sure that's not true, right? There's no way that negative 12 and 30 are the same thing. Like, they're not even the same number, let alone this one's negative. This could never be true, no matter what happens. So, never true. It's nonsense, never true. Let's look at another one. Here. Okay, I'm seeing we could distribute, right? 2x plus 12 equals 2x plus 12. Hey, wait, let me read that again. 2x plus 12 equals 2x plus 12. It looks like the same thing on both sides, right? 2x and 12 and 2x and 12. Those are literally the exact same thing. Like if I plugged in 0 for x, like 2 times 0 here and 2 times 0 here, those would both be 0. You have 12 equals 12. Test it out with some other numbers. This one's always true. 2x plus 12 is always going to be the same as 2x plus 12. They're literally the exact same thing. Let's do another one. I'm seeing that we got distributed again. So 3x minus 2 equals... Oh, Mr. Mailhot. I made a mistake. 3x minus 6. Multiply. Let's go. Equals 3x minus 2. What are you thinking? I'm seeing 3x and 3x on both sides. But from one of them, you're going to take away 6, and from one of them, you're going to take away 2. Let me say that again. They both have 3x. They both have the same term, but from one of them, you're taking away more than the other one. You're taking away more here than you are here. From the same thing. Like $30 minus $6 and $30 minus $2, not going to be the same, no matter what. And we could do the same thing we kind of did up here, and get the subtract the 3x and subtract the 3x, and you have negative 6 equals negative 2. That is never going to be true. Alright guys, finish out these last ones, right? Oh, let me, I almost got ahead of myself. This here, and then I'll leave you at this. Remember, this is not x squared plus 16. This exponent, it doesn't just distribute through. This really means x plus 4 times x plus 4, right, which you'd have to distribute each term. Okay, finish those up. Come to class with questions. Remember, we're mathematicians. We can do anything we want. See you later.